Good evening and welcome. I'd like to speak to you today about some of my research and the power of design thinking. One of the most common phrases that teachers hear is, when are we ever going to use this? I'm sure you have reflected on this many times. The work that I'm about to describe is really centered on translating research that is being conducted at the university into new K-12 STEM contents. I call it iDesign and iSTEM. In this model of research, STEM teachers are taught to co-plan together. The children are taught by actually 3 teachers working together, unpacking what is often very abstract science, technology, engineering, and math concepts. As students grow in their learning of STEM, the block often happens when the concepts become abstract. The power of this work is that students learn across their common classrooms, with the teachers in each classroom focused on the same design problems. This aids in connecting the STEM dots. The way we do this is the teachers design engineering challenges that mirror research in the classroom. For example, my work has centered on designing biosensors to understand how cells in the brain communicate. This is a very difficult engineering design challenge. But when we give that same challenge to kids to find out how ants communicate, it makes the connection to more advanced STEM work. Teacher teams, student teams, long-term 15 weeks, engineering design as the focus. That gives us real practice, real process, and cross-cutting thinking. The results of this work, the results of the student work, are then presented publicly, just like scientists, in K-12 classroom posters. So it mirrors exactly the scientific practice. In this work, the results have initially been quite promising. Children in classrooms who have been turned off to mathematics and science, when presented with design challenges, all of a sudden get excited about participating and working with others, teaching each others to learn and how to accept failure. The connection of the STEM dots has shown us 2 very promising results. One, I mentioned, is that they get excited about learning, they learn in teams, they communicate, but the results of this work, after working with nearly 500 students, is that their math and science scores are starting to signal changes consistent with this work. The power of design thinking and new ways to organize kids in classrooms and how teachers teach them. The power of design. Thank you.